Alright, now that we know the multiplication and division rules, we can justify some of the more fundamental rules of exponents. First one has to do with an exponent of 0. So, let's pretend for a second that we don't know any of the rules. If I wanted to figure out what x cubed divided by x cubed is, I would simplify them. X cubed means I have 3 x's on both the top and the bottom. And just like with the multiplication rules, this means this turns into 1 times 1 times 1. So we really just end up with 1. And we know that any number divided by itself always gives us 1. Nothing new. But now if we use our rules, when we have division, we need to take our exponents and subtract them. So we end up with x to the 0 power. So now we have these two different things. That x cubed divided by x cubed equals 1, but that it also equals x to the 0 power. So because we started with the same problem, that means those two things have to be equal. 1 and x to the 0 power are equal. And that leads us to rule number 6. Not only is x to the 0 power equal to 1, any number to the 0 power equals 1. So we write the rule like this: x to the 0 power equals 1. So, moving on to the next rule, and this is actually the last rule that we need to learn for exponents. So, simplify again. Forget that we know the rules. This means 5x's on the top, and on the bottom I'd have 7. So some of these are going to cross off. The first 5 will actually, and we'll be left with 2 of them. But these 2 x's are not in the numerator, so we can't write x squared. They're in the denominator, so we need to leave them there. Can't move them to the top. So on the top, we need to have 1 as a placeholder. So this is our answer. We're dividing by 2 x's, or x squared. So now let's use the rules. Rules say that I would need to subtract 5 and 7. When we get our answer, we end up with a negative number, a negative 2. So, negative exponents just means that we are dividing by 2 x's in this case. So, again, just like before, means that these two things have to be equal. So that leads us to rule number 7. Any number to a negative exponent is 1 divided by that exponent, and you change it positive. So negative exponents technically mean division, and we show that by doing 1 over x to the nth power. So let's do some practice. Go ahead and pause the video, see if you can do these on your own, and then we'll start the notes again. Alright, so these are the answers you should have gotten. Hopefully the first 3 were pretty easy. The fourth one is a trick question. You cannot have 0 to the 0 power, because that means at some point in time you had 0 in the denominator of a fraction, and we know that's not allowed. If you forget that one, type it into your calculator. It will say error. The next examples, leave them as fractions. Do not tell me what 1 divided by 125 is in a decimal. So make sure you leave it as a fraction, because it's something you can figure out without typing it into your calculator. So, here are all the laws that we have talked about. This very first one is one that we didn't really mention, but it is an exponent law. If you have any number to the first power, that means you just have 1 of those numbers. And then this one right here is the exact same as this guy right here, just with a 1. So no need to memorize both of them. Remember, the awesome thing about these laws is you don't need to memorize any of them. You can always prove them using the same steps that we did in the notes. So, how do I know when I'm done simplifying? You need to check for a couple things. First of all, you cannot have negative exponents. If you have negative exponents, you need to simplify them. Second thing you need to look for is you need to have unique bases. That means all of your bases should be different. If you have 2 x's, you need to simplify them. If you have 2 numbers, see if you can simplify them. You can't have powers of powers, so don't leave anything like x squared to the 4th power. That's something we can simplify. You also can't have powers of products. So I couldn't have x squared times x to the fourth. We can simplify those. And then all of your coefficients should be relatively prime. So if you have an answer that looks like 6x squared y, all divided by 8z, don't leave the 6 and the 8 unsimplified. Reduce these guys to 3/4. So just because we're dealing with exponents doesn't mean you can just forget about simplifying the actual numbers. So now that we know all of these rules and we know how to know if we're done simplifying, try these ones. They're similar to the ones we did in class today, but give these guys a try. Go ahead and pause the video, and then when you think you have it, turn it back on and you can see the answers. Remember, if you got these wrong, to mark them, put a star next to them or something so we can go over them in class on Monday. Alright, so we're finally done with all of our exponents. We now need to talk about powers of 10 and scientific notation. So before we can start talking about scientific notation, we need to understand powers of 10. So powers of 10 mean that I need to write these numbers as 10 to some number up here. So 10 times 10 times 10 times 10. How many times do I need to do that to get these numbers here? So we can kind of do process of elimination. If I just gave you this right here, it would just be 10 to the first power. I have 110. If I had 2 zeros there, it would be 100, or 10 squared. And we could keep doing this. 10 cubed would be the next one, 10 to the fourth. Or the neat little trick is count the number of zeros. 1 0, like we have right here, and just 10, means that I have 110. So if I count on my zeros, I have 3, 6, 9, I have 10 zeros. So this number that I have up there is the same exact thing as 10 to the 10th power. I'm going to multiply 10 together 10 times to end up with this 10 billion. Skip the one in the middle for a second and let's figure out this last one. Again, I want to write it as a power of 10. So if I forget about all these other zeros, this would be 10 to the first power. If I forget about these ones, it would be 10 to the second power, or 100. Forget about these ones, it would be 10 cubed. Forget about just these, 10 to the fourth, 10 to the fifth, and then finally we have 10 to the sixth power. Or again, I have 6 zeros, so that's how I know it is 10 to the sixth power. So both of those numbers had positive exponents. That means this guy, since it's a small number, is going to have a negative exponent. Instead of multiplying by 10, we want to divide by 10. So how many times do we need to do it? Well, let's think about numbers we know. If I have 1 divided by 10, I get 0.1. So there's 110 there. If I have 1 divided by 100, which remember is the same thing as 10 squared, I end up with 0.01. So in order to figure out what I need to count just the numbers after the decimal. Not just the zeros, but also include that 1. Here I have 2 numbers after the decimal, and my exponent is 2. Here I have 1 number after the decimal, and my exponent's 1. So after the decimal, I have 3, 6, and 7 numbers. So that means 0.0000001 is the same thing as 10 to the negative 7. Or I divided by 10 7 times. So now we're going to multiply by the powers of 10. You can do a couple things. You can type these into your calculator, or you can move the decimal. And you move your decimal the same number of spaces that you multiply by 10. This is, again, what makes the metric system so awesome, is there's no real calculations here. I know if I multiply by 10 9 times, what I'm really doing is taking this decimal and moving it 9 times. So I'll move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Now all these spaces, I need to leave myself some zeros. So here's my number. Looks kind of messy, but it is 1, 2, 3. It is 23,890,000,000. That's what 23.89 times 10 to the 9th is. Let's skip this one right here. And let's do the next one. 12 million times 10 to the negative 6. What this really means is I need to divide by 10 6 times. So just like we moved the decimal for the very first one, we can move the decimal for this one. And in order to get division across, I want to move the decimal to the left. So I'm going to move it 1, 2, 3, 4, 5, 6, and it ends up being just 12. 12 point with all those zeros is the same thing as just 12. So we need to talk about this thing called scientific notation. There are two parts to it. We have the digit part and the size part. The digit part is just a number. The size part tells me how many times I'm going to move the decimal. Go ahead and read through this. So, using all that information, which one of these following is in scientific notation? There are 3 options here. Hopefully you pick 2.4 and 6.0. And this 4.9 blah 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 blah. The other 2 are not in correct scientific notation because they do not have a digit 1 through 9 in front of the decimal place. So the next couple, change them into proper coefficients. So for this first one, where should the decimal go? In between what 2 numbers? Hopefully you said 4 and 6. And then all these other numbers follow. Let's skip the next 2 and do the very last one. Where does the decimal need to go? In between the 3 and 2. So why do we need to know all this? So that we can do some scientific notation stuff. So the size part, we already talked about the digit part. The size part tells us how big or small the number is. So if you have a positive exponent number, you are going to have a big number. If you have a negative, you're going to have a small number. Remember, the positive means you're multiplying by 10. You're making it bigger. The negative means you're dividing by 10 or making it smaller. So go ahead and pause the video and see if you can answer these next 3 questions. You should have gotten big, small, small. So now we are going to convert from normal numbers or standard notation into scientific notation. Go ahead and pause the video again. See if you can do these, and I'll put the answers up, and let's see if you can get them correct. So apparently the video didn't pause. Hopefully you got a chance to work through those, and those are your answers. Now we're going to go backwards, converting from scientific notation to standard notation. So what you need to do for these is multiply by 10, or divide by 10, that many times. So if I have 5.6 times 10 to the 4th, I need to move my decimal 1, 2, 3, 4. So my new number is 56000 for 56,000. Skip this one and move on to this, 5.12. Since it's times 10 to the negative 6, I need to move backwards. 1, 2, 3, 4, 5, 6. Run out of room, but we fill all of these in with zeros. So we end up with this number right here.